Welcome back to my YouTube channel. Today I will solve a question of a JAM exams. Okay. Question is given that n greater than equal to 2 be an integers and define a map A from Cn to Cn. Okay. Which is a linear transformation and defined by A z1 z2 zn equal to zn comma z1 z2 dot zn minus 1. Okay. Then which of the following statement is true for n greater than equal to 2. Okay, now solve. Now solution. Okay, here given the linear transformation A Cn to Cn. Okay, and defined by A z1 comma z2 comma dot zn, this equal to zn comma z1 comma z2 comma dot zn minus 1. Okay, and first of all we find the matrix representation of the linear transformation A. Okay, so now standard basis we already know that e1 e2 dot en, where ei is the ith coefficient is 1, other coefficient is 0. Okay, so now find the value of the e1 e2 and dot en. Okay, so a1 comma 0 0 0, that is equal to 0 1 0 dot 0. Okay, and a0 comma 1 comma 0 dot 0, this equal to 0 0 1 0 dot 0. Okay, similarly, and also similarly we can find other elements, and so the image of 0 0 dot 1 comma 0, that is equal to here 0 0 dot 0 comma 1. Okay, and also the image of the 0 0 dot 0 comma 1, this equal to 1 comma 0 dot 0. Okay, and this is written as 0 comma e1 comma 1 comma e2 comma 0 comma e3 plus dot plus 0 comma en. Okay, similarly we can written this 0 comma e2 comma 0 comma e1, sorry, here e1, and 0 comma e2 plus 1 comma e3 plus dot plus 0 comma en, and similarly this is also written as 0 comma e1 plus dot plus 1 comma en. Okay, and this is also written as 1 comma e1 plus dot plus 0 comma en. Okay, now so matrix representation of A B equal to, that is equal to 0 1 0 dot 0, and here also 0 0 1 dot 0, and so on. We have finally we have here 0 0 0 dot 1, here this lower diagonal elements all are 1 and otherwise 0, and here last columns is 1 0 dot 0. Okay, now, and you also know that we also know that any monic polynomial, suppose x to the power n plus a n minus 1 x plus dot plus a naught, this is written as the matrix form, written as component matrices of this polynomial is 0 0 dot minus a naught. Okay, and here 1 0 dot minus a1 comma dot, this is 0, and here 1, and this is equal to here minus a n minus 1. Okay, and here also 0 0 0, and this element 1 1 1 1 dot 1. Okay, this type. Okay, and do you also know that this monic polynomial is minimal polynomial of this matrix. Okay, so find the minimal polynomial of B, that is mbx, this is equal to, now comparing this, okay, we can find here x to the power n, okay, and all are 0, coefficient equal to 0, so last coefficient is -1, okay, so this is equal to -1, okay, so this is a minimal polynomial of p, okay. So now find the root. So we can find if we find the root of minimal polynomial, we have the eigenvalues, okay. So this equal to x to the power n minus 1 equal to 0, that is x to the power n equal to 1. So we have root of unity, and you already know that if alpha is a root this equation, okay, so modulus value of alpha equal to 1, okay, and if we here choose n equal to 3, so root of unity is, root of the equation is 1 omega square, okay, this. So option of the question is, first option is false. Why? Because we already know that every important matrix only 0 eigenvalues, contains only 0 eigenvalues, okay, or every important matrix have 0 eigenvalues, okay. So this is false because already here 1 is non-zero eigenvalue, omega is non-zero eigenvalue for n equal to 2, n equal to 3, okay, and this option is true, option number B, because modulus values equal to 1, okay, modulus values equal to 1, this is true, and option number C is false because 0 not an eigenvalues in this case. And now singularity, the rank of the matrix, this matrix, here non-zero row, count the non-zero row, here non-zero row, here because here 1, and this also non-zero row, here 1, and this is also 1, and so on. So rank of the B equal to n, so that means that is equal to columns, so that means this is a non-singular, but here given singular, this is a false option. So answer of the question is B, okay. Thank you.